virtual private clouds, and security controls. Welcome to this Virtual Private Clouds, VPCs, and security controls. As businesses migrate to the cloud, securing network environments is more critical than ever. A virtual private cloud VPC allows organizations to run isolated cloud environments within a public cloud infrastructure, providing better security, performance, and control. However, improper VPC configurations can expose sensitive data and applications to cyber threats. In this lesson, we will explore how VPCs work, their security risks, and best practices for securing cloud-based networks. Let's get started. A virtual private cloud VPC is a logically isolated section of a public cloud where organizations can deploy resources like virtual machines, databases, and applications while maintaining control over their network settings. VPCs provide a secure, private environment for cloud-based workloads. Think of a VPC like a private office space in a shared building. While the building itself is open to many tenants, public cloud users, each office space VPC is isolated with private access and security controls. Similarly, businesses use VPCs to run workloads in the cloud without exposing them to external threats. For example, an online banking platform can use a VPC to host customer transaction systems while restricting access to authorized users only. Here's how to set up a secure VPC. Use private subnets to limit public exposure of sensitive resources. Implement access control lists, ACLs, and security groups to filter network traffic. Enable encryption for data at rest and in transit to protect sensitive information. Understanding VPC components is essential for securing cloud-based networks. A VPC consists of several key elements that control traffic, security, and connectivity. First, subnets. A VPC is divided into subnets, which can be either public, accessible from the internet, or private, restricted to internal access. Second, route tables. These determine how traffic moves between subnets and external networks. Third, security groups and network ACLs. Security groups act as virtual firewalls for cloud resources, while network ACLs provide additional traffic filtering at the subnet level. Fourth, Virtual Private Network, VPN, and Direct Connect. These allow secure connections between an on-premises data center and a VPC, enabling hybrid cloud environments. For example, an e-commerce company can use a public subnet for its website front-end while placing databases in a private subnet, restricting external access. Here's how to secure VPC components effectively. Place sensitive workloads in private subnets with no direct internet access. Use security groups and ACLs to define precise traffic rules. Monitor route tables to ensure secure communication between subnets. While VPCs enhance security in the cloud, they also introduce risks that must be addressed. First, misconfigured security groups and ACLs. Incorrect firewall rules can expose VPC resources to unauthorized access. Second, weak authentication. If access to a VPC is not properly secured, attackers can gain unauthorized control over cloud resources. Third, unencrypted data. Without encryption, sensitive data stored in VPC resources can be intercepted or leaked. For example, an improperly configured VPC might allow unrestricted SSH access from the internet, making it an easy target for brute force attacks. Here's how to mitigate VPC security risks. Restrict inbound and outbound traffic to only necessary IPs and services. Require multi-factor authentication MFA for access to VPC resources. Enable encryption for databases and cloud storage services to protect sensitive data. VPCs often need to connect with on-premises data centers, third-party services, or other cloud environments. Ensuring these connections are secure is critical. For hybrid cloud deployments, organizations use VPNs or Direct Connect to link on-premises infrastructure with VPC. These connections should be encrypted and properly monitored. For multi-cloud environments, VPC peering enables secure communication between VPCs in different cloud regions or providers. However, improper peering configurations can expose data to unauthorized networks. For example, a healthcare company using VPC peering to connect patient data systems across cloud regions must apply strict ACLs and security group rules to prevent data leaks. Here's how to secure VPC connectivity. Encrypt all connections between on-premises and cloud environments. Use private endpoints instead of exposing VPC resources to the public internet. Continuously monitor and audit VPC traffic to detect anomalies. Let's look at a real-world example of how a financial institution secures its VPC. A global bank migrated its core banking applications to the cloud using a VPC. However, security assessments revealed vulnerabilities, including open ports and weak access controls. To mitigate these risks, the bank implemented private subnets for all financial data, restricted administrative access to specific IP addresses, and enabled encryption for all stored data. Additionally, the bank deployed intrusion detection systems, IDS, within the VPC to monitor for unauthorized activity. As a result, the institution enhanced security, reduced attack surfaces, and ensured compliance with financial regulations. Here's how to secure a VPC like major financial institutions. Use private subnets for sensitive workloads. Implement strict access control policies using IAM roles and security groups. Deploy monitoring and logging solutions to track all VPC activity. Now, let's summarize what we've learned about virtual private clouds, VPCs, and security controls. VPCs provide secure, isolated cloud environments within public cloud infrastructures. Key VPC components include subnets, route tables, security groups, and VPN connectivity. Security risks include misconfigured firewalls, weak authentication, and unencrypted data. Best practices include using private subnets, enabling encryption, and enforcing access controls. Continuous monitoring and auditing help detect and respond to security threats in VPC environments. By following these best practices, organizations can leverage VPCs for secure, scalable cloud networking while protecting sensitive workloads. This concludes our module on virtual private clouds, VPCs, and security controls.